Welcome to the Cimatron webinar. My name is Andy and I work at Technical Support. Today we will be covering the Shank and holder dialog settings implemented in version 15. As we move through the presentation, please put any questions into the chat area, and at the end of the presentation we will do our best to answer all of them. Before version 15, the old dialog you see on the right here was what we had to work with. It was often confusing to set up, and it offered no visual aids as to what was happening. So often we couldn't get a tool in where we needed to, or it was just too hard to understand what was actually happening. The new dialog at first doesn't look a lot different. What we want to emphasize here is the most common setting you want to use is simply setting the Shank and holder to use. It's the easiest to set up, there's nothing to modify, and it gives you a safe and fast result. There are times where changing those settings can make it faster to calculate and use, but on average the best option is to leave this on use. Now, another option you have is ignore, which is just not recommended, but in some cases it does apply. The last option, which is what we're really covering today, is advanced. When you feel the need, or there is an application where the tool simply isn't going to get where you need it to, or maybe you need the minimum length of the tool, we need to switch the Shank and holder settings to advanced. This is particularly helpful for tool clearance when it's a tight fit, or maybe the Z is too close. Let's take a little more look at this. Something we'll want to keep in mind today is the options are procedure dependent. Some sliders, depending on the procedure in, may or may not be available. One of the things that you'll notice when you open the dialog is the gray at the bottom of each slider column. The cutter flute length and the full clear length are always considered against the accurate part. So there is no adjustability here. They're always going to be considered for safety and accuracy. Here we're looking at the default view when you have the Advanced tab open. So you'll set it to Advanced, and the only thing you'll see is an Access button. Click on that Access button and this is the view you'll see. By default, this window is collapsed and it's a good start. What we want to keep in mind here is when you're in this view, we always want to work from left to right with these sliders. You don't want to jump around out of order. So the very first column is the one that you want to work with. Once we have this set, we can worry about the rest. Ignore considered tools elements. This is the first column and we have to set this before doing any of the rest. This tells the procedure what part of the tool assembly to check for collisions with. In the example to the right, the flute and the shank cannot be ignored for collision checking. The second and third holder stage is ignored for collision checking since the slider is moved down. Notice the ignored holder stages are grayed out. Now in the second column, since we've set the first, I've slid the first column all the way back up so we can consider all elements here. The second column is where we tell it what part of the tool assembly is going to be looking at the part and what is going to be looking at just the stock. In the example to the right, the first stage, the bottom of the holder, is checking against the part surfaces only. So if we look in the second column, if we see blue, it means that we'll not be looking at the stock model. If we look up top where the orange is, that will be checking against the part surfaces and the stock. So as we slide that up and down, orange is checking against part and stock. Blue is checking against part surfaces only. This is important to remember because when we consider both the part and the stock, this will increase the calculation time. It's a safer result, but it will take more time to do this. So when you're making these changes, keep this in mind. The last column we have is the grid mesh representation. Grid equals less accuracy but faster calculation. Mesh equals higher accuracy but slower calculation. This is important to remember on a file. If you have a large core or something like it and there is a ton of motions, if you crank this up too high, especially against the holder and the shank, this could cost you a lot of time in calculation. By having the option to slide this up and down and affect what part of the tool assembly is seeing the grid versus the mesh, we can find a happy medium, a good compromise for our calculation, but also get an accurate, safe result. So let's dive in and take a look at this new shank and holder dialog. Here we have a toolpath that's a guided cleanup. I run the navigator, place the tool, and we do a side view here. We can see that this tool is actually long enough to reach down into the groove that we're trying to machine, but we did not get motions all the way around. So with a little quick check here, we can turn on the stock, and now when we run the navigator again and just quickly place the tool down here and do a side view again, we can see that distance we thought we had is cut in half because of the additional stock that's still on the part. So this is a good scenario where using some advanced settings with the holder could be very beneficial. If we edit the procedure, we go down to shank and holder, switch this to advanced. We have an access button here that gets us into the new dialog. Now just like we said, we're going to work left to right. We're going to have all of the tool elements considered here. It's not going to hurt. The next thing to figure out is we know that this second column, if we see orange, it's considering both the part and the stock when checking for collision. So what we're going to do is come down here, go ahead and slide this up, and for the first stage of the holder and for the extension on the tool, we're going to check against the part surfaces only and not the stock. This is just one way to do this. We'll green check. We'll go ahead and calculate. This time, when we have the stock not being part of the calculation and collision checking, we'll run the navigator again, and we can see when we look around here, we have toolpath motions all the way around the part. Even when we get around these areas that are a tight squeeze, it's removed the motions where it's up against the part, but it went ahead and did all of the rest of the groove where it could. So this is one way that you can manipulate that collision checking. When we go back into Access and we look at some of the values that are in here, I'm going to go ahead and slide this back so we have our holder checking again. If we look over here on the holder Z safety value, you can see the default is 1 millimeter. Generally speaking, we can change these values. They're within your control. It is best to leave them be. Make your changes over here. If you absolutely need to, go ahead and change this, but it shouldn't be your first resort. By default, this pane will be collapsed. All you're going to see are these options here, and this is going to allow you to do the vast majority of anything you're going to need. Now when you get over into here, one other button that's useful, calculate minimum length up to, and in this case we have holder 1, because looking at the tip here, we have our cutter extension, and then we have the holder. This is holder 1 right here. Now when we say calculate minimum length, below that you can see we have an additional setting. What do we do with the motions that it finds are a collision? We can remove them, we can create them as a holder prevent motion, or we can create as a regular motion. When you choose regular motion, nothing changes with the toolpath. You'll get a value, a number that outputs, and then the collisions will be allowed to happen. The idea is you'll go back and manually clear that tool. It's not the safest option. If you're in the habit of doing it, that's fine. Generally speaking, I'm going to recommend staying with remove. If you have a collision, it'll take those motions out of the toolpath. So if you choose to use this, what happens is you're going to green check, you're going to save and calculate, and then you're going to go up to View, Pane, Output Pane. Now, in the very bottom, you'll have a number. So if we look, now that this is done, it says the minimum clear length of the cutter up to including holder stage 1 is 24 millimeters. You can leave this open or close it, but now if I go to my cutter and I look, if I add up the lengths of my tool and the shank, they're not quite 24 millimeter. So we need to increase that slightly, or I have to use the advanced settings to change what it's checking to get the tool motions I need. So just an example of some other options you have in that dialog and how to interact with it. We're going to hop back over, talk about the grid and mesh safety values. When you're in the panel in the top right corner with the advanced settings, you'll notice that there's a drop down for the grid size, and then you can see the grid safety and mesh values. As you change the grid size from the default, you'll also notice that the values further down for holder and shank safety, things like that, they'll move, they'll adjust based on that grid size. The grid size can affect the access to certain regions on a part or multiple parts. So if you're cutting, let's say, 4 identical parts, but they're spread out on fixtures over a large area, if you're cutting with a small tool and it doesn't seem to want to go over and cut the other tools, that's a grid issue. It has to do with what that's set to. So making adjustments there can make all of that go away. Now, the smaller the grid size, the higher the calculation time. The mesh safety values depend on the procedure tolerance. So the tighter that is, the smaller the value. That's going to wrap it up for today. As a reminder, we have our main website to check out at Cimatron.com. If you're a North American customer, don't forget you can reach out to us at support-us@cimatron.com or call us at the main number shown, same number we've had. Thank you for checking out our webinar today. Have a great week.